This is reading number 4 from Module 3, Earth's Resources. Water resources. Location of freshwater resources. Water distribution is a continuing problem worldwide, even though most continents have plenty of water. Since the 1970s, scarcity of water has resulted in the deaths of more than 24,000 people each year. In areas where water is scarce, women and children often walk long distances each day to collect water for domestic uses. Millions of people also try to survive on land that is prone to drought. About 25 countries, primarily in Africa, experience chronic water shortages. Dams and reservoirs. Building dams is one of the primary ways that countries manage their freshwater resources. Large dams are built across river valleys, and the reservoirs behind dams capture the river's flow as well as rain and melting snow. Because the runoff is captured, flooding downstream is controlled. The water held in these reservoirs can be released as necessary to provide water for irrigation, for municipal uses in homes and businesses, or for producing hydroelectric power. Reservoirs also provide opportunities for recreational activities, such as fishing and boating. Dams and reservoirs currently control between 25 and 50% of the total runoff on every continent. Pause and go answer question number 12 on page 12 in your science notebook. Desalination. With great quantities of water available in the oceans, some countries have explored the possibility of removing salt from seawater to provide fresh water in a process called desalination. There are several methods for desalinating seawater. One is through distillation. Water is heated until it evaporates, and then it is condensed and collected. This evaporation process leaves the salts behind. Most countries that use desalination to produce fresh water use solar energy to evaporate the seawater. Although the evaporation of seawater by solar energy is a slow process, it is an inexpensive way to provide needed fresh water. Some desalination plants, such as the one shown in the diagram, use fuel to distill seawater. But because this process is expensive, it is used primarily to provide drinking water. Both processes require large amounts of energy. Pause and go answer question number 13 and number 14 on page 12 in your science notebook. Energy resources. Earth's main energy source. The energy that humans and all other organisms use comes mostly from the sun. How is solar energy used by organisms? Plants are producers. They capture the sun's light energy in the process of photosynthesis. The light energy is converted into a form that can be used for maintenance, growth, and reproduction by the plant. When organisms called consumers eat producers, they use that stored energy for their own life processes. For example, when a rabbit eats grass, it consumes the energy stored by the plant. The rabbit stores energy as well, and this energy can be transferred to other organisms when the rabbit is eaten, when the rabbit produces waste, or when it dies and decomposes back into the ground. The photo shows how trapped light energy can be transferred from plants to humans. Humans use energy to keep them warm in cold climates, to cook food, to pump water, and to provide light. There are many different fuel sources available to humans to provide this energy. Most of these fuels, like food, also store energy that originated from the sun. Pause and go answer question number 15 on page 13 in your science notebook. Fossil fuels. Energy sources that formed over geologic time as a result of the compression and incomplete decomposition of plants and other organic matter are called fossil fuels. Although coal, oil, and natural gas originally formed from once living things, these energy sources are considered non-renewable. Recall that non-renewable resources are used at a rate faster than they can be replaced. Fossil fuels are non-renewable resources because their formation occurs over millions of years, and we are using them at a much faster rate. Non-renewable fossil fuels, oil, coal, and natural gas, are used to generate approximately 80% of the total energy consumed for electricity, heat, and transportation in the United States. Fossil fuels mainly consist of hydrocarbons and can be transported wherever energy is needed and used on demand. This is why most industrialized countries, including the United States, depend primarily on coal, natural gas, and petroleum to fuel electric power plants and vehicles. Although fossil fuels are diverse in their appearance and composition, all of them originated from organic matter trapped in sedimentary rock. Pause and go answer question number 16 on page 13 in your science notebook. Coal. Coal is the most abundant of all the fossil fuels. Recall that coal forms from peat being compressed or squished over millions of years. As compression continues, the hydrogen and oxygen in peat are lost and only carbon remains. The greater the carbon concentrations in coal, the hotter it burns. Most coal reserves in the United States are bituminous coal. Therefore, many of the electricity generating plants in the United States burn this type of coal. Pause and go answer question number 17 on page 13 in your science notebook. Peat is a light, spongy, organic fossil fuel derived from moss and other bog plants. Peat is not coal, but a required first ingredient. Peat can be burned as fuel, but is not used as widely as coal. Incomplete decay of plants forms peat. Lignite is a soft, brown, low-grade coal with low sulfur content, less than 1%. Because the carbon concentration in lignite is generally around 40%, it is inefficient as a fuel. More lignite must be burned than other types of coal to provide the same amount of energy. Peat is buried and compressed to form lignite. Bituminous coal can have carbon concentrations as high as 85%. When bituminous coal burns, it releases carbon dioxide and gases containing sulfur and nitrogen, causing air pollution. After further compression, bituminous coal forms. Anthracite can have a carbon concentration as high as 90 to 95%, and it stores more energy and burns cleaner than other types of coal. However, fewer than 1% of the coal reserves in the United States are anthracite. More heat and pressure are applied to form anthracite. Pause and go answer question number 18 on page 13 in your science notebook. Solar energy. Have you ever used a calculator with a solar collector? Solar-powered calculators derive power from the sun's energy. As you learned previously, the sun is the source of most of the energy on Earth. The main advantages of solar energy are that once the generator is constructed, it is cheap and produces little pollution. You have learned that plants transfer energy provided by the sun to other organisms by being eaten. Solar energy can also be used directly to meet human needs through passive and active solar heating. Passive solar heating. If you have ever sat in a car that has been in the sunlight, you know that the sun can heat up the inside of a car just by shining through the car's windows and on its surface. In the same way, the sun's energy can be captured in homes. Thermal energy from the sun enters through windows, as shown in the photo. Floors and walls made of concrete, adobe, brick, stone, or tile have heat storing capacity and can help to hold thermal energy inside the home. These materials collect solar energy during the daytime and slowly release it during the evening as the surroundings cool. In some warm climates, These materials alone can provide enough energy to keep a house warm. Solar energy that is trapped in materials and slowly released is called passive solar heating. Passive solar designs can provide up to 70% of the energy needed to heat a house. Although a passive solar house can be slightly more expensive to build than a traditional home, the cost of operating such a house is 30 to 40% lower. Solar heating is considered a good alternative to conventional energy resources because it is clean and readily available in some areas. However, sunlight is available during limited hours each day and is difficult to store for later use. Active solar heating. Even in areas that do not receive consistent sunlight, the sun's energy can still be used for heating a house. Active solar heating systems include collectors, such as solar panels that absorb solar energy, and fans or pumps that distribute that energy throughout the house. If kept away from trees, solar panels mounted on a roof can have unobstructed exposure to the sun. Energy collected by these solar panels can be used to heat a house directly, or it can be stored for later use in insulated tanks that contain rocks, water, or a heat-absorbing chemical. Solar panels mounted on the side of a house, as shown in the photo, can heat water up to 149 degrees Fahrenheit, which is hot enough to wash dishes and clothing. The panels in this picture are made of black tubes filled with water. The sun heats the water, and the water is pumped into the house for use. Pause and go answer question number 19 on page 13 in your science notebook.